Thank you very much. So it's a great pleasure to be here. So thank you very much for the introduction. So what I wanted to talk about here today is to talk about this. How do we actually try to build more trustworthy and factual large language models? And this is based on an EU project that I'm coordinating. But just to kind of set the scene, I think it's kind of important just to realize the fact that AI development is very fast. We have seen tremendous progress the last 10, 15 years. But I also think it's important to realize that this tremendous progress that we've seen and very impressive applications is actually based on very long-term basic research. So even though from a kind of general population point of view, it feels like things just appeared, this is actually something that's been developed over, about 80 years or so. But I think one of the tools and the applications that people use the most today is this large language models. And I think they're very fascinating in the sense that they're so generic. Most of things in our society, in our culture is text and language based. And by using these language models, we can now start to analyze, generate, organize, and so on, do a lot of things with this text. And I think the number of applications that we can think about using language models is basically infinite. And I don't think we have even starting to scratch the surface of what we can actually do with these. So I really think this will be a key technology going forward. And of course, now we see more sophisticated applications or usages of these language models are being built. So for example, this deep research where the AI system can then collect, you basically ask for a report about something, it then goes out and collect relevant sources and then put together a report according to your specification. It's also the kind of basis for building what's called agentic systems, basically tailoring different language models for different particular roles, and then putting together organizations with these different roles so that this system then can address and tackle more challenging problems, such as here's an example from Google on their AI scientist, where they then have these kind of language models doing many of the things that we do in the kind of scientific process, such as doing literature review, simulating that you have a scientific discussion, identifying research gaps, generating hypotheses, checking these hypotheses, collecting results to a paper, being the reviewers, and then updating the paper. And basically all the different steps we can think of can then be emulated. Now I think there was a paper at ICLR, one of the ICLR workshops earlier this year that was accepted after peer review, after being fully automatically generated. So then it went through the normal reviewing process, and that was accepted to one of these workshops. So I think this kind of applications will be more common. Just to kind of as a starting point, I think we see a lot of interesting trends when it comes to this development, that we're now moving from kind of unimodal to multimodal models. We're looking from not just only this next token prediction to more reasoning models. I will get back to it soon. And also that we were expanding or kind of complementing machine learning with more symbolic techniques, for example, neurosymbolic AI, and also going from language models to world models, which of course we have seen many examples here today, that you want to make these models actually relevant in the physical reality, and you want these models to be able to produce things that make sense in the physical world and the other way around. And also that we're going from this more human-driven chat interactions to more agentic system. So I think there are a lot of interesting trends in this space. I also think this will have a major impact on society. I just took one example here regarding work. This is a study that I think is close to 2 years now, where they basically looked at the number of 700 to 800 consultants at Boston Consulting Group in the US over a large number of different activities. And they found that those that were using these kind of AI tools could get more things done in the same time. Each task took on average 25% shorter time, and you could also increase the quality with 40%. So basically you got more, faster, and better by using this kind of AI tools. So I think the impact on society and on work will be significant, which of course makes this very important. And then we have this kind of issue that since I think this technology is really going to be a key technology on which I think many other things will be built, I find it highly problematic that we basically don't really have any European alternatives. I think Mistral in France is the closest that we have, and mostly we're using American or Chinese technology in this area. So I really think this is a strategic challenge for us in Europe, and of course we want to help doing something about that. And I mean, now the European Commission has launched the AI continent, where they want to do investments and activities so that we in Europe actually can be a serious place to do this kind of AI development. And they have a number of different initiatives in order to support this. And I think this highlights one thing, which is the importance of ecosystems, because I really think the key here, if we want to make a difference, we really need to work together, and that we need to connect like basic research to more applied research, to educational activities, to infrastructures and so on. So this is just a kind of a sketch of the different initiatives we have in Sweden, because this is one of the things that I've been pushing. How can we get a good research, innovation and education ecosystem, and to get these different initiatives to work together? And I think we'll probably talk more about that after lunch in the panel when we talk about how to kind of build this kind of ecosystems. And of course, Linköping University is one of the key players in this, at least in the Swedish context. So actually we're the host of many of these national and also international initiatives. So for example, we're the host of Sweden's largest research program, WASP, the Wallenberg AI Autonomous Systems and Software Program, which is a 600 million euro, 15-year research program, where one of the goals to educate at least 600 PhDs in the areas of AI, autonomous systems and software. So far, I think we're getting to 200 finished PhDs soon at least. So it means that the next coming years we're going to educate at least 400-500 more PhDs. So it's on average 1 PhD defense per week in the coming years. So I think that's a bit of a scale. So there I was responsible for building up the graduate school. Now I'm a co-director but responsible for collaboration within this program. We also have a EuroHPC, and now we have an AI factory that's going to be built. So we also have the infrastructure. So actually we had Jensen Huang visiting us a few weeks ago when he became an honorary doctor at our university. So we're really trying to get the infrastructure as well for enabling this. And then we also work with educational activities and also very much on the EU level. I mean, we talked about Taylor, which I coordinated. We're also involved in ADRA, which is the AI Data and Robotics Partnership in Europe, which is then the kind of partner with the Commission. So we are involved in writing the work programs together with the Commission, and there I'm responsible for leading our work on our strategic research, innovation and deployment agendas. So I really think this just to show that there is a lot of things going on. I think if one wants to really have an impact, you need to combine all these different things. So now I will go from this kind of broad perspective, going into a bit more of the things that we are working on in this TrustLLM project. And that is, of course, we're working with language models. So again, I think it's important to realize that, I mean, language models have been developed for a long time. So it's not just something that popped out yesterday. So there is a history and a tradition for developing different generations of technology. But today we're using mostly the GPT-based models. And actually it's kind of interesting because this first part, the GPT, the generative pre-trained transformer, actually the first version was in 2019, I believe. So I mean, that kind of general language models has been around for 5-6 years. But it was not until we started doing fine-tuning and adaptation. So we got this ChatGPT in November of 2022 that they really had a major broad societal impact. Then we added this retrieval augmented generation technique on top of that, where you basically add context to your prompt before it's sent to the language model, which deals with a lot of the challenges and significantly improves the quality of the output. And of course, then the last year or so, we have seen this kind of reasoning models that they're sometimes called, where you basically, instead of just generating the most likely continuation of a text, you can actually start to have some kind of inner monologue where these language models are then generating multiple different continuations, and then either kind of just counting and seeing what is the most common answer and then selecting that, or summarizing it, or doing something with all these different answers. So it's actually using the language model in a bit more sophisticated manner. And then again, we can improve the quality, at least on certain types of problems. I think it's also important to realize that there is also studies regarding how to scale this, because I think one major aspect of building these language models is scaling. And then there are these kind of scaling laws which then relate the size of the model, the amount of data that you have, and the amount of compute you have. So basically, if you fix two of these, for example, you say, oh, this is how much data I have, this is how much compute I have, what is the largest model I could do? Or you want to do a model of a certain size, you have a certain amount of data, then you say, oh, how much compute do I need in order to actually train this optimally? So we can predict with some reasonable quality what the results will be of training these models. But now, of course, we also see that this kind of scaling landscape is becoming more complex. So it used to be just the scaling of the pre-trained models, basically the size of the model, amount of data. But then we also need to do the post-training scaling, so doing the adaptation, fine-tuning, alignment, and these kind of things. And now we also have this test time scaling, where you actually have to spend significant amounts of compute in order to compute each answer to a query. And I think this is, of course, different because the pre-training and alignment and so on, that's basically amortized over many usages, while the test time is per instance, unless they do some fancy caching and so on. But I think that's a bit trickier. So I think it's also interesting to see this kind of development of these language models as well. And now there are studies trying to understand how sophisticated tasks can be achieved with these language models. And according to this study that came out, I think it was in March, they have come to the conclusion that the most sophisticated models at that time could solve tasks that required humans about 1 hour to complete. But they also came to the conclusion that if we look at the development, the time it takes to double the length of the task that these models can complete has then been doubling every 7 months, which means that around Christmas, these models will be able to solve tasks that takes 2 hours. About next summer, it's 4 hours, and then early 2027, it will then be 8-hour tasks can be completed by the most sophisticated models. And actually, since this has been out for a few months, they've actually looked at the latest, say, O3 models and came to the conclusion that O3 is significantly above this curve. So maybe the rate of doubling is even faster than 7 months. If I remember correctly, they said every 4 months, which means that then it would be about a year from now, we would have models that can solve tasks that take us 1 working day to complete. Personally, I don't really think it matters if we take 1 year, 3 years, or 5 years. I think the point here is more that the quality and the capacity and the capabilities of these systems will continue to increase, at least into the foreseeable future. And then we will see if there really is a kind of a ceiling or not. I guess we will find out. So we have now established both the kind of quality and a little bit how these models work. But I also think it's important to realize that we cannot really trust these models. And we have the European approach to AI, which is really this, that yes, we want AI, but we don't want any AI. We want AI that we actually can trust, and that's what we also say is human-centered. So it's not the technology itself, but it's what this technology can do for us that matters. So therefore, I think it's important that, I would say that you probably cannot trust ChatGPT or your other favorite language model, but if you're aware of this, it's still extremely useful. So I don't argue that's not useful. It's just that we cannot just blindly trust it. We need to check and to make sure that what they produce make sense. But that is, of course, something we wish to improve on. So the overall purpose of the TrustLLM project is really how can we increase the trustworthiness, and also how can we increase the factfulness, because I think those are also closely related. That, if they're making the correct, generating the correct output, then we have a better chance of trusting them. And we are doing this basically covering the full scope from data collection to pre-training to post-training to evaluation and so on. So, and one of the reasons is that I think one of the key aspects of building trustworthy AI is transparency. We want to know what data has these models been trained on, how have the kind of training process been configured, and so on. And basically that we do not know of these kind of large, more commercial models, and probably we never will get all the full details. So that's why we need to do this from the start. Our focus is on the Germanic languages, and the reason for that is two. First of all, the partners that we have are all from Germanic-speaking countries, but also because we believe that, or our hypothesis is that if you have languages from the same language family, there's bigger chance that they actually reinforce and support each other compared to having languages from different language families. And we have also selected partners which are already kind of leading the national developments within their countries. So for example, in Sweden, we have AI Sweden, which has been developing a Swedish model. We have TNO in the Netherlands that is developing the Dutch GPT-NL, which is the Dutch model. We have Fraunhofer and Jülich, who has been involved in OpenGPTX in Germany. Medind, who has been working with OpenAI on trying to get ChatGPT to support Icelandic, and still it does not really perform super well. And so on. So we're really trying to get these organizations that already have experience and that are leading their national efforts so that we can build on and extend that. So this is a research project. So in some sense, the focus is on doing research, but we also really want to actually create artifacts. So training our own models. And one reason is that if we want to be able to evaluate the quality, we really need to actually train these models. And if we want to see how this works in real applications, again, we need the models to be able to do that. So therefore, we actually need to train models ourselves and also do evaluation. So what we have said is that we want to train at least one model every year. And then we want to increase its kind of quality over time. So now we have trained a kind of baseline model the first year so that we have something to compare on. And basically the first round is then more taking what we already have. And then over time, we want to replace and improve this. And in some sense, what we want to do in the end, so actually we had a consortium meeting on Iceland this week. So I just came back from Iceland on Saturday. And then we said, so what do we want to achieve? Because of course there is always this question, why should you bother? Can you even compete with the really large players? And then we said that one thing we want to do is that we want to be basically state of the art in at least one language. And probably Icelandic and Faroese is going to be at least two of those languages, because those are low resource languages, which the kind of large models are poor at. But of course we hope to be able to do it for more languages. We want to be transparent about the data use, but also how we actually train the model so that you as researchers understand how we have done it and can build on it, because that's a challenge today. We would also like to have permissive licenses. And actually, this is, I think, actually the hardest part. So everything around the legal aspects has turned out to be the biggest obstacle and the biggest challenge in this project. So basically, I've already said this, but I mean, we have created a baseline model, and now we want to iterate and improve this. And I think one thing that we also want to do is to understand what are the challenges, especially when it comes to these legal aspects, which we have spent a lot of time on. So even if we might not succeed in training the models, we want to understand what would it take to actually succeed. Basically, the development process looks like this. So it's, as I told about before, we have the data creation part, pre-training, post-training, evaluations, and applications. So if we then look at from a kind of a trustworthy and factual aspect, so what do we do? So what are the things that we do in order to improve this? So I would say transparency is kind of number one that we want to do, that we want to be open with how we do things. We want to be compliant with GDPR, Copyright, AI Act, and so on. But the major challenge is that no one can really tell us what's needed. And so it's really challenging to even get an answer to the question, what do we need to do? And you basically get different answers depending on who you ask. And so on. And then it's also that we have different organizations that making slightly different interpretations. So therefore it becomes even more challenging. But what we would like to do in some sense, the goal here is to develop data processing pipelines so that you can plug in the data, and by applying these filters and so on, in the end you will get compliant data. Because so we want to translate the kind of legal requirements into something that's implemented in code that you can run on your data to, for example, remove personal identifiable information or removing copyright information and these kind of things that you need to do, identifying the licenses and so on. So that's what we're working on. We're also looking into synthetic data as one opportunity here. But then you have this interesting argument, what if you use synthetic data from a kind of non-compliant model? Is then the synthetic data compliant or not? Again, no one really knows. So actually this is where we have had to spend more time than we wanted. And then the pre-training, so here we're also looking into tokenization. So I mentioned that Icelandic is really challenging, and one reason is that the tokenization, so the kind of grammatical structure is different, which means that you need more tokens in Icelandic compared to, say, English, and the quality of the models scale according to the number of tokens. So therefore you get worse quality in Icelandic because you need more tokens to do it. And one reason is, of course, that they have this kind of special characters that requires multi-byte Unicode encoding and so on. So there are a number of things that we're trying to do in order to improve the tokenization. We're also looking into energy efficiencies using kind of more efficient representations and trying to find the smallest models that we can to solve the problem and so on. So a number of things about energy efficiency. When it comes to post-training, it's very much around alignment and actually around collecting alignment data in our mostly low resource languages, because it just doesn't exist in, say, Swedish or Norwegian or Faroese or Icelandic and so on. I guess German probably is the largest languages that we do. We're also looking into how to use this kind of post-training with reinforcement learning to improve the factualness. I have an example of that later. And also, how can we increase the factualness by using knowledge retrieval augmented generation, so that you can basically have your knowledge encoded in, say, knowledge graphs and so on, and then feeding it into the process through the RAG component. And we're also doing multilingual evaluation. Yeah, of course, there's a lot of more details. I don't have time to go into them. Challenge is data availability. And this is just to compare a little bit. So you can see that English and code, there is a huge amount of data. German actually shows up pretty okay, Dutch as well, Swedish is at least visible, but in many other languages there is extremely small amounts of data. So this is kind of one of the key challenges. And actually, we also found out that if you look at this kind of open data sets, it turned out that parts of these were basically also automatically generated, so just translated. So it wasn't original in that language. So actually finding sufficient amounts of high quality data in all languages is a challenge. One thing that we have been working in my group is on synthetic data generation. So basically learning generative models of kind of sensitive data and then using this to generate new data. We have been doing this more for time series and for healthcare records in a fair and representative manner. Now we're interested in, can we extend this and also use it in text generation? So this is just what I already also said a little bit about how we work with data creation. That in some sense, what we want to do is to build a data processing pipeline, which then filters out all the content which is non-compliant, and that we can then improve and extend the amount of compliant data and then grow this over time. We have a number of aspects just to deal with both static knowledge, so for example, this knowledge RAG that I talked about. If we're also interested in dynamic knowledge, so things that change. And here we have one of the challenges that the language models don't really have a sense of time. So how do you extend them with an understanding of what time is? So you can ask about what is true at different points of time is one thing we're also interested in. And then when it comes to alignment, so this is really about how do we get these models to not only kind of produce, let's say, statistically reasonable output, but also outputs that we as human users really want. And luckily, there are some results stating that you basically need a relatively small amount of high quality data. So actually, that's what we're trying to do, is to collect this high quality data in our languages. So that we have these data sets that we can then share and thereby support this development. So when you do alignment, you can work on many different levels. So the kind of more pre-training, again, it's about quality there, but we also have instruction fine-tuning and we have the preference fine-tuning. So our focus is more on the preference fine-tuning and then collecting preferences from our countries and our cultures. Yes, and we were using a different variety of data. But we also have this challenge on how to actually evaluate the systems, and including language models. And actually, I think this is going to be one of those really challenging problems, because the more sophisticated your language models or your AI systems in general become, the harder it will be to actually verify and evaluate them. So towards this end, there was one more thing, and that is, if you look at existing leaderboards, they're basically using this kind of different kind of standard benchmarks like ARC, GSM 8K, and so on. But if you actually look into this, they're basically all about English language and American culture. So there was this paper describing this MMLU. And if you look into the specifics, they have all these different categories of facts and things that they check. But if you then look into this, you can see that there are certain categories which are explicitly American, like high school US history, US foreign policy. If you take something like global facts, it turns out they have 21 questions about the US, 7 questions about China, 4 questions about India, and then 16 other countries that have 1 or 2 questions. So again, it's not really representative of the global kind of facts. Formal logic, again, even when the formal logic, it's English sentences and how to translate these English sentences into logic. So again, it doesn't cover other languages. There is like medicine, and then it also refers to prior knowledge based on the American educational system. If you take anatomy, then it's basically using, again, English phrases for that. Yeah, you kind of get the picture, yeah. So it doesn't really matter, even if you take this subject matter, it's still very, very English and US centered, which means that, just go on and on. Yeah, more American law. So yeah, accounting standards in the US, yes, and yes, keeps going. So basically the challenge here is really that even when you have this kind of the benchmarks, which are supposed to cover like more kind of global or general knowledge, it's still very much regional or culturally dependent, which means that if we want benchmarks that's actually relevant for, say, European perspectives, we will need to create them ourselves. So currently, what we do is basically automatically translate it from English to whatever language you prefer. So basically have synthetic data. But if you really want this to matter for us, we need to create them in our own languages, in our own cultures. And that's what we have been starting to do in this Euro-Eval framework. So, of course, we have started with the languages that we have, but it's now being extended also with Italian and French, and Spanish is about to be added. So here there is kind of a framework that's being developed by Alexandra Institute in Denmark to support this. And they cover a number of different natural language understanding tasks, such as sentiment classification, named entity recognition, linguistic acceptability, and reading comprehension. And actually, when it comes to this linguistic acceptability, one thing we found out is that if you take, say, one of these large, say, US-based models, you ask it to generate, say, German, it will generate German for a while. And then at some point, it will switch back to English. So it's kind of like you probably have your favorite language and you can force yourself to speak another language, but if there's no reason, you will switch back to your preferred language. And it's kind of the same with these language models. So the longer you generate it, the more likely it is to switch to another language. And of course, now with these kind of reasoning models, we can see that they switch to Chinese and other languages in the meantime while reasoning and so on. So it's also kind of interesting to see. We also have 7 natural language generation tasks. Sentiment classification, named entity. I will not read it, but basically we have tried to cover the kind of key things that you want. And then there are leaderboards in the different languages for this. So you can evaluate different models, how they perform on different languages. And then the final thing I wanted to mention is the work of one of my PhD students, Hora Fakkar, who has been looking into applying this GRPO on these kind of models. And what's interesting is that you can actually increase the quality significantly with this kind of post-training. So actually this is based on research by DeepSeek that they have been developing this reinforcement learning techniques to improve the correctness after post-training. And we can see that, so I mean, she managed to kind of increase the quality of our model from 5%, so it was really low, but actually up to 29%, actually being almost on par with Mixtral's 7B model just by doing this. So actually by using reinforcement learning to basically push the model to generate more factual results, you can significantly improve the quality. So this is just a kind of ongoing research, so it's not published yet, but this is, I think, very interesting results. And of course, I mean, as I already mentioned, we are basically covering the full spectrum. So this is just to kind of show the structure from data creation, pre-training, alignment, also model transfer. So one of the things we wanted to look into or want to look into to deal with low resource languages is looking at model transfer. From what I understand, the results are not that promising, so maybe it wasn't that the approach that we had might not really work out, but at least we're interested in studying that. And we're also working with a number of companies to see if they can apply this, so we can get feedback from real use cases. So that's interesting. So to conclude, I have tried to both kind of situate, I mean, what is going on in kind of broader perspective on pushing the state of art in AI technology, mainly these language models, and then kind of identifying that there is a need to develop these kind of models here in Europe, because no one else will care that much about our languages and our cultures. And I also think it will be very important to have this kind of technology, because I think a lot of kind of other applications and usages will be built on top of them. And therefore, we have then been working on this TrustLLM project, where we take a holistic perspective on how to develop more trustworthy and factual language models, from data creation to pre-training, post-training, and evaluation. And we're also very much interested in engaging in the kind of European ecosystem and to work together with others. And we try to be as open and inclusive as possible, because we think that it's the best way to achieve the results we want is to work together. Thank you very much.